Hi, welcome to Google's official Android developers YouTube channel, powered by and dedicated to developers just like you.
No matter if you want to learn a library more in depth or just keep up to date with what's new in Android and Play, we've got you.
With over 1 million subscribers, we're proud to cultivate a community of creativity, curiosity, and coding that's never been so valuable.
We are dedicated to providing you with the most informative, relevant, and inspirational content as possible.
So no matter where you are on your learning journey, we are right here.
Guiding,
Listening,
And supporting.
Let's develop together. Hi.
Welcome everyone to day 2 of HackFest 2022. Today is the commencement of our first of the 4 workshop bootcamps planned as part of the Learners track at HackFest 2022. Today, we will be joined by distinguished speakers from Google developers who will be sharing their invaluable knowledge and experience in Android development. Before I begin, this is a notice that this virtual event will be recorded for student activity and promotional purposes. By entering this session, you consent to have photos or videos taken of you and your voice. So this is the agenda of the session today. So we will start with the introduction session by Mr. Hassan Abid, and followed by the session by Mr. Saurabh Arora. Then we will have a Q&A session and we'll wrap up. Now, introducing to you our speakers for the event, Mr. Hassan Abid and Mr. Saurabh Arora. The first sharing session will be conducted by Mr. Hassan. Mr. Hassan is a passionate software engineer with several years of experience in Android and web development. He's currently based in Singapore, where he works as CTO for a Singapore-based company, BeLive Technology. Before that, he lived in Seoul, where he worked for Next Streaming Corp. With the Next Player SDK team. He worked on KineMaster, an Android video editing app in the same company. He loves writing and sharing his experiences about Android development with fellow developers through blog posts, events, and conferences. Hassan, I would now like to pass my time over to you. Thank you.
Hello, everyone. Hello. Let me share my screen. Second. Hopefully everyone can see my screen. Let me make it a bit bigger. Okay. So thank you, Rachel, for introducing myself. So today I will be talking about the general overview of mobile development for Android apps. Actually, after this, there will be another session about modern Android developments, but before that we need to set some foundation. So this talk will be generally for everyone, not necessarily Android developers, but people who are aspiring to be an Android developer. And because during the hackathon, right, different people get together and then they might want to develop an app or website or something. So this talk will generally give them some idea of what's possible with Android. So before, I would just like to introduce myself. I'm working as a CTO at BeLive Technologies. So I think here you can see our new office. We just moved to our new office at One North and started coming back to office. Previously, I joined this company 4 years ago as Android developer, but I transformed myself, like learning about different technologies. And currently, I'm leading the team. We have around 35 plus developers based out of Singapore and Vietnam, and also contributing to Google developer events by speaking at conferences. You know that before 2020, it was used to be in person, but since 2020, because of COVID, everything is online. But hopefully that next year's HackFest will be conducted in person. So I'm able to see people sitting in front of me, because talking to myself like this, looking at camera, looks a bit weird every time. Okay, so I worked on different Android apps in the past. One of the app was video editing app, and it got so many users. So now I think it's like crossing 115 million mark. And then other than that, now we are developing some live streaming technology here to make it like easy for people to integrate, because, you know, with this hybrid kind of workforce, right? Everything is hybrid. You used to go to a mall to buy something, but now you can also buy something online, right? So, but you need to see something. So that's why my company is basically working on this live technology, which supports hybrid model. Okay, so before that, I'll just give some context as to why Android, and share a bit about my Android journey, and then various ways we can develop an Android app, and then about Kotlin, which is the main language for Android development. Then after that, we will look into how it is different from Java, and then lastly, we will look into some advanced Kotlin, but I will not go much detail. Next talk, which Saurabh will be talking about, will go a bit more deep into some of the things I'll discuss here. Okay, so Android is very easy to learn, and it has very easy entry into the market, because almost 80% of all the smartphones are Android devices, and Android is open source, which means like you can basically get all the source code, modify it to your own needs, and then you can just like release your own OS. So this is how many of the big companies are doing. And then there's a lot of job prospects across Asia, across US, across Europe, and most of the apps on Android are free. It means like more users will be downloading the apps. And you can see that by 2024, Android will have 86.2% of the market share, which is like very huge. And then here you can also see that this was a survey conducted on Stack Overflow, and what they asked like many developers to respond, right? And then you can see that among the app development, Android is like among the top 5 ones. Of course, the Linux is like, you know, everyone wants to do some server stuff. They are playing around with this, but Android was the top 5 things they mentioned, which people are using. Okay, so my Android journey started from 2011 when I started learning to developers.android.com. Then I joined some Android study groups back in 2011. That time, I tell you, it was very hard because I didn't own an Android phone. So mostly we could use emulators. And then I got my internship in 2012 to do the tablet UI. Then after that, once I learned something right, I shared back to the community. There was an online course on Udacity, which we conducted some sessions, which this was called Android Study Jam. And after that I also continued to study by myself to finish Android Nano degree in 2015. And once I'm sharing this all Android stuff through Google, through blog posts, through speeches. I was selected as Android GD in 2016, and then it continued when I moved to Singapore in 2018. So this was one of the talk I gave in 2015, 7 years ago. Maybe most of you will be middle school students by that time. And then I shared like how we learn Android from Google, like all the official resources. And then you can see like Android has came a long way. It started from 2008 and now it's actually 2022. So Android 13 is the latest beta version out there. Yeah. And there are like over 2.5 billion active devices by 2019. I think this number has maybe doubled by now. Okay, so as of now, right, Android 12 is officially released last year. And just recently, Android 13 was also released as a beta. So people can already download on some of the limited phones and start testing the new features. And for Android Studio, yesterday, a new version released called Chipmunk. So they have started naming like these, but you can see like here also some funny names like Jelly Bean, Kit Kat, Lollipop, Marshmallow. Yeah. Okay. And then you can see like Kotlin is the preferred language for Google has selected it. So there's no more development done in Java, but this doesn't mean that Java support is like removed from Android Studio. No, Java is still supported. These are some of the official documentation links. You guys can check. Okay, okay. Let me go to next slide. So just want to see if everyone is listening to me. Okay, let me go back. So this is the new Android Studio logo. Actually, I really liked it, Chipmunk, whenever you start Android Studio. And so Android Studio, there's a stable version. Then there are some preview versions. So the latest pre-version is called Dolphin. So they've also come up with these kind of names, which keeps you interested. And this is one of the screen you are seeing is something like where you know you can see your kind of code, your layout code on the left. Right side you can see immediate preview, and then let me go to the next one. Okay, so this one is image view. Okay, so where you can actually drag and drop to change the view, which was not possible in the earlier versions of Android. It was not very stable. Then we have this new way to build the UI. It's called Jetpack Compose. I will just have a couple of slides about this. And then you can see the preview here. So actually you are coding in Kotlin, you're building your views, and you can see like the preview on the right side. So it's very exciting thing with Android Studio. Okay, let's go to like how we can develop Android apps. So there are several ways which we can use to develop Android apps. There's native and cross-platform. So native is generally use Kotlin or Java. Then there are other ways like where you can use React Native, Flutter. There's a web view. Yeah, and there is Unity. There's this platform on C#. Then there's Kotlin multi-platform. So there are different ways you can develop Android apps, but there's always a debate like which one is best of them. But generally native is the best for long-term app development because it gives you all the features of Android OS. Flutter and React generally is like when one developer is developing for both the platform. but there might be some performance issues, but generally, I mean, it depends on what kind of app you want. I can just give an example that Grab Food app used to be React Native before, but then they moved it to the native Grab app. So I mean, there are some pros and cons always. If you want to launch your app to market fast, then maybe Flutter and React Native will be good. But if you're looking for long term, then native is the way to go. Okay, so why Kotlin? Kotlin is recommended by Google, and it started in 2017. So even before, many developers were using Kotlin, but after 2017, it was made official language for Android. And then you can see that Kotlin's popularity is increasing day by day, and it's one of the 4 loved languages among all the languages. So this is like the survey is done by many developers around the world. And then you can see that Kotlin is among the top 4 languages. Okay, also, this is another website which ranks programming languages. You can see that Kotlin is like getting a lot of interest, and this is the popularity on GitHub. So it's like, this was actually taken 1.5 years ago, but now you can see like this will even go further up. And these are some of the apps which are built with Kotlin. These are some of the popular ones I have noted here, but in Singapore also all the top apps you can think of, right, which you use on daily basis are mostly built with Kotlin. And there's like a course about Kotlin 101 developed by JetBrains. JetBrains is a company which developed Kotlin, but Kotlin is also open source. And it's a modern, statically type programming language. It's very pragmatic and concise, and also works very well with Java. So you can have Java and Kotlin side by side. You can call functions from Java to Kotlin and Kotlin to Java. So that's why it was not difficult to transition from Java to Kotlin for people, because you write your old functions in Java, right? You can call them in Kotlin very easily. So that's why people started writing new codes in Kotlin, but the old code still remain in Java. But when they get time, they could update that as well. So this is some like basic structure of Kotlin. You can see like, okay, here we have a class. Then we have this main activity. So I'm particularly focusing on Android here. Then we have this is extension of app compat activity. Then you can see like we can have this fun function on create. Then we have this question mark, which is nullable and non-nullable type. I will explain to you later. And then we don't need to have semicolons. They are optional here. Yeah, and yeah, so it's like more modern style of development. And you can use this template expression. For example, you want to append a variable. Before that, like in Java, we need to do format, or we need to like do comma and put the variable name, right? But here you can actually append variable inside a string using this $sign. Okay, let me go to next one. So Kotlin versus Java. So on the left side, you can see the hello world on Java. We always start with hello world, right? On the right side is just a function, because Kotlin is like you can write functions, but for Java always need to have a class. Yeah, and you can see that number of lines of code already reduced by nearly half. Okay, now we will focus on what Kotlin has that Java does not. So basically in Kotlin, right, we can do something like this. Okay, we have a variable, and then, okay, so here we're trying to say that we cannot set a variable as null, but in Java, actually you can set a variable as null. But you can see that if I put a question mark there, right, then this can be a null as well. So this will actually prevent your null pointer exceptions. Okay, so then there is, I'm just explaining that part. Once the case one is like where you set like your variable is a normal variable, but somehow through some API response, it got a null value. Then you will get some compiler error. You need to protect this case. How you will protect this case? We'll put a question mark. So this will help you to avoid null pointer exceptions and improve your code, because Kotlin Android Studio will not let you compile your code. So these are compile time errors. With Java, we won't let you know. And then we have null conditions. So basically, you can see that once we we can do this kind of null check. So this is also very useful. And once we do this right, after that, we can start using this variable already in our code without forcefully unwrapping this. So this is also one advantage of Kotlin. And there are safe calls. So safe calls is like, for example, we can do this question mark dot length. So it means like even this B is null, right? This will not affect anything. Yeah. So it will not have any unnecessary, like it will not throw any exception or something, but for Java, it will surely give you a null pointer exception. Okay, we have this operator to forcefully unwrap as well, but I mean, sometimes it's not recommended unless you are absolutely sure what you are doing. Okay, so now we have some extension functions. So for example, your normal classes are, for example, string doesn't have any, has limited functions, right? You can create these extension functions and they can actually, this is an extension function actually we are creating. And then you can use throughout your code. So these are kind of helper functions. And you can see that now our mutable list has a new swap function we can use in our code. So these are very, very powerful and important in Kotlin. And then we have data classes, which comes with like a lot of useful stuff, because we need to store our data, whichever data we get through API calls, and they comes with like very default features, get and set. Yeah. Yep. And then we have smart casts. So smart cast is like, for example, if you say X is string, then it will assume that X is string. After that, you can just call x.length. So this is a pretty good feature, but Java, you need to forcefully have a type for that. And then we have smart cast for when expression as well. So you can see like is int, is string, int array. So you can interpret like this as well if you're not sure about that, what type of the variable that will be. And then there are some Android Kotlin extensions. Actually, this might not be in use as I can recall from my memory. So I'll just, because all these good features are already built into Android. Okay, so I go to coroutines. Coroutines are some lightweight threads, so they are generally used for the async tasks. Previously, like we were using async tasks, and Android had quite a bit of issues with Java, but with coroutines, actually, we don't need to use any external library. We can use the libraries provided by Google and Kotlin to basically do all the background work for network or any heavy task we are doing in our app. So maybe later, I'm not sure, Saurabh might share more about this. And then, so this is one example I share about coroutine. Actually, there are async calls. So just let's see, usually what you do is like there's a network call. After network call, right, you get some data and then you do save data in your database. So generally the flow works like it's a sequence. you have to do like wait for the result, and then after that successful network request come back, then you can save that result. But with the coroutines, actually it makes it very simple to write. You just need to write like them in a sequence. You don't need to do like wait for the result or something, but this coroutine will internally handle, and once the result is ready, right, it will come to this line of the code. And those are like very lightweight, so it will not block your UI, and reading the code is also more easier, and also you can manage your flow. So there's like another new cool thing about Kotlin is a Kotlin multi-platform. So basically you can use Kotlin to develop Android app, your server apps, your iOS apps, and you can also develop browser-based apps. And this is still like in development, but some companies have already tried Kotlin multi-platform and they have got good results. Okay, let me go to, so basically, like you can go to this website where is play.kotlinlang.org. I will share these slides with you guys, and then you can try out Kotlin by yourself. So it will show you both iOS and Android. This is for Kotlin multi-platform actually. So there are some discussion about Android architecture as well. So that you will hear about model view presenter, clean architecture, MVVM, and there's like some Android app architecture from Google. So every architecture has their pros and cons. But I think the idea here is that like you want your apps to be scalable. Yeah. So generally you will join a company, they will already be using one of the architecture and you need to learn through it. So basically it's kind of template to develop a new feature more faster, so that easy to test, easy to write test codes for both UI and unit tests. And also many people can contribute together. So, so I just write down here, right? I'm not go into detail, but you guys can check and read about this. For hackathon, maybe not very necessary because don't have usually time, but if for your own learning, right, it will be good to read about them. Okay, so there is another new cool thing which is called Jetpack Compose. And basically, what's the Compose? So Compose is you can use Kotlin to create the UI. So this is actually something for iOS, they have Swift UI, and it works on the newer versions actually. So because Kotlin is itself very powerful, right? So why not like use it to build our UI as well? Then you only know Kotlin, and then you can build both UI and your functionality together. Because currently for Android development, you need to build your UI in XML, or you can write some custom views or custom UI code as well, but you need to connect both of them. Yeah. Okay, I see someone joining the room. Okay. Okay, so these are the official documentations, which you can find it here. And then some of the learning resources I'm sharing here, they are Kotlin only docs. It's pretty cool. Kotlin is a very good language. Then there are Kotlin for Android docs. Then there is a lot of labs available for Kotlin. And then there is Android developers YouTube channel. So it's good to know about all these official resources. So the code labs, right, generally you go to this website, codelabs.developers.google.com. You can find different categories. It's not only Android, it has like a lot of Google tech out there, but you can find Kotlin only. So here I selected Kotlin, but you can find Android. You can even find Google Cloud or other technologies as well. And this was actually Android Dev Summit. It happens every year. I used to go in person, but now it's all online. And just do watch out for Google I/O happening this month. There will be a lot of new cool features coming in as well. and you can watch this online on YouTube for free. And this is Twitter. So on Twitter also you can follow the Android trend. Then you will hear from all these famous developers or people who are working at Google. They share about new stuff. They have their own blog posts. They have their own sample apps as well. On their GitHub, you can go and find out as well. Then we have the Udacity, which is a free online course website where a lot of Googlers have their official courses. So this is also a good learning place. Then we have this nano degree, which you can use to showcase if you're looking for jobs. They give you a certificate. This is my certificate from 2016. Yeah, you can put in your LinkedIn profile. You know, it's like good to have this, right? It's a 3 to 6 months course, but now they have like for starter and more advanced people as well. Yeah. And then there is a associate Android developer certification as well. I put the link here. And then you can also update your repositories to share your code. Here I'm just sharing my own repositories, which like I build some Android apps and I just share with people. Yeah. And actually you can also use Stack Overflow if you are stuck anytime. So, but like you see, this was closed on Stack Overflow because usually you need to ask a problem. So here the person asks like how to learn Android development efficiently. Okay. Yeah. So yeah, this is like generally for asking questions, not for learning Android development. And I think just like my friend used to say that, okay, learn, then teach, and then show off. So showing off is like when you will kind of build something in your hackathon, then you can show off to people. Okay, thank you so much for your time. Thank you.
Thank you, Mr. Hassan, for the insightful sharing session. And I'm sure the participants today had numerous takeaways from the same. We will now move on to our second speaker for today, Mr. Saurabh. Saurabh is a Google developers expert and a senior engineer on the Android team at Twitter, Singapore, where he works on both the mobile and TV apps. Outside of work and meetups, he's a big teams and cricket fan. He also regularly plays tennis and squash. Saurabh, I would now like to pass on over the time to you.
Thank you so much. I'll start sharing my screen. I guess that will override yours. All right. Are you able to see my screen? Can I get a thumbs up or a confirmation?
Not yet. It just says that you have started screen sharing, but nothing is coming up.
Okay, that's weird. Let me retry. Now?
I think from my side, I cannot see. I'm not sure about the others.
That's weird. It keeps on telling me, just let me try again. That's weird. Now?
Yes, can see. Yeah.
Yes, can see now.
And now?
Yep.
You see the main screen, right?
Yeah.
Okay. All right. Then if everybody's able to see, then let's get started. Hi, thank you for the good introduction, the warm introduction. I'm Saurabh Arora, as she mentioned, a GD in Android. And today I'll be talking about just giving you all a brief run through modern Android development. Just a quick idea about why modern Android development, like why I thought about this. I think when somebody's starting off with Android, especially in these times, you would end up looking at quite a lot of blog posts or resources or like talks from the past to actually learn Android and brush up. And you run across different paradigms on what people are talking about is the right way to build an Android app. So there's the past way to build Android app, like because Android has been development for like, we're talking about Android 13 now, so close to 13 years, right? So there was this classical way of building Android apps, and now we have this new modern way of building Android apps. So it's good to understand what are the new practices and paradigms. So when you're like looking up resources or when you're trying to study on your own, you can make the distinction between, you know, what is old and what is new. So if it's something which is old, maybe it's no longer true, maybe it's no longer the recommended way of doing things. So you can not really end up spending time on that, but rather, you know, pick up the new modern, the new recommended patterns of building Android applications. All right. So with that in mind, let's start. So first up, like as I said, like over the years, there've been many talks about modern Android development. Like if you go to YouTube and you search modern Android development, you'll probably run into this talk from Android makers in April 2018. There's another talk in DevOps France, Google I/O May 2018, same, what's modern Android development. 2019, modern Android development, and here we are 2022, and I'm again talking about modern Android development. So the thing is that, as I said initially at the start, you know, as times change, as technology evolves, the concept of modern changes. So what was modern earlier in these previous talks is actually a classic Android development now. So, you know, to give you let's just look a bit more in to give you a bit more understanding. Let's do a quick history tour and a history lesson of what Android was. So somewhere around 2007, 2008 is when Android came out, right? And you had your SDK M3, that's the mainline version 3, Java programming language, platform APIs, Eclipse ADT, APKs. This is when Android was officially launched. You had 1.0 somewhere in 2008. You had more platform APIs come along. Android Studio comes along 2013. You get Kotlin support in 2017 and architecture components in 2018. And I realized Compose was always on my screen. But okay, 2021, you now have Jetpack Compose. So that's your history tour. And as you can see, classic Android development to modern Android development is how we've progressed as time goes on. Oh, and app bundles as well, but we'll get into that. So previously, what we had in classic Android development, you had the Java programming language. The reason Java was chosen, big, large developer base, which we had, existing tools, free tools, existing libraries, patterns, best practices. Java was extremely popular, is extremely popular. Like I wouldn't say was, is extremely popular as well. So when Android went ahead with using Java as a programming language, you got lots of patterns, best practices, industry-wide research already conducted into what's the best way to write code. You had a robust automatic memory management, I mean, as compared to C++ at that time, right? Java also brought along their own set of programming tools for you. You had Eclipse ADT, which was free. It provided a familiar developer experience for people who were using Java on the front end already for, you know, Java desktop apps, or people who were using Java to build backend apps. So they got a familiar development environment by using Eclipse. And ADT is the Android developer tool. And it was free. I mean, that's the biggest sell, right? Android was free. The tools were free. And the IDE was built in such a way that you could plug in new subtools and components into the IDE. And that was excellent because even those tools were free. And what's best for free? Like if you want to get a new set of people enthusiastic and start adopting your technology, having it free is definitely the best way to go forward. And definitely the previous APIs were kind of good. Like we can say it was kind of okay, because there was the new APIs always came bundled as a part of the platform, and the platform had new releases frequently, extremely frequently in the beginning, because it was a new API, it was a new platform, there were bugs, they were being polished. So it was great to have new releases frequently. But eventually the challenge is that the newest release has the bug fixes, but Android, users don't really update to the new release. So you would end up with users being on the previous version of the platform, and you cannot use new functionality that was offered in every releases, and you'll have to wait for the bug fixes to come out. So this is what it looks like 1.0, 1.1, 1.5, so frequent, and then sparse. And this is where we are right now, 2022, 12. So every new release, every new feature, all classic Android development, you have to wait for the new update to come out. And then you have to wait for user adoption to happen. And that's where you can start building features that will actually reach your users, right? And lastly, let's look at classic Android development again, how your app was distributed. They were distributed using APKs. APK is just like a zip file, zipped up for your convenience. But what if you have more configurations? And here, more configuration is like, oh, I want to have a different APK or a different app for people on phones versus people on foldables versus people on Chromebooks versus people on tablets. Then more configuration, more APKs. And or you could not do more APKs. You could just bundle all that information inside one APK, and you could at runtime decide what kind of screen or device the user is using and switch in your configuration accordingly. So what that meant, bigger APKs. So that's how Android development has been for quite a long time. And these classic Android development architecture framework had classic problems, like in terms of language, Java, pretty good, excellent, but verbose. Tools, Eclipse plus ADT, I said earlier that you could plug in subtools, but difficult to customize. It didn't have the amount of customization and flexibility which you would need to build on a ecosystem as vast as like Android. And subtools tend to have inconsistent UIs. The core ID itself, Eclipse, was not being actively improved and maintained, and Android or Google's team actually had no control, right? Previously, in terms of APIs, like the third pillar we went through, it was a part of the platform. As we said, every release would get new features from within the platform. So developers are limited by users getting new releases. Once they get new releases, then only we'll be able to adopt the new technology and the fixes in them. And most users for a long period continue to be on old releases. They're like using phones which haven't got any updates for 3-4 years, and developers are facing problems in, how do I build new features that everybody can get? And APIs are complicated. Like, let's be honest, lifecycle, storage, navigation. It was a challenge. I wouldn't say it was a mess, but it was still a challenge for regular folks. So, and distributions, as we said, big APKs and many APKs. So if you're releasing an update and you had 3 APKs on the App Store to figure out to target your users, you updated one, but you didn't update the other 2. You forgot about it. Turns out your phone users got the new feature, but your Chromebook users did not get the new feature. So the answer to all of these problems is modern Android development, or as the Android community likes to call it, MAD. So what's modern Android development here? It's as we said, the 4 things we talked about: new development tools, new APIs, new language, new distribution technologies recommended by the Android team to help developers be more productive and create better apps that runs across millions and billions of Android devices that are out there in the market. So what does modern Android development look like? We'll try to split it into 4 pillars, as we've discussed earlier: language, tools, APIs, distribution. And I think from here onwards is the core crux of the problem that I'm trying to address here, that these are the new frameworks and technologies you should look out for if you're picking up Android right now. And if you're reading a blog post, as long as they talk about these new methodologies, which we'll just dive into it from the next minute onwards, they are your best friends, they are your pals, and they are the recommended way of learning Android. If you run across some of the previous stuff that I mentioned, like APKs, stuff from Java programming language, Eclipse, platform APIs, just rest assured you can most of the time skip them. It's no longer needed or relevant if you're starting off new to Android right now. So first up, modern language, Kotlin. Hassan did touch on it quite a bit, so I'll keep this short and sweet. 2016, Kotlin launched. Middle of 2017, Google I/O. Google officially supports language for Kotlin as the official language supported for Android. 2019, Google I/O, Kotlin goes Android first. 2020, coroutines preferred. 2022, watch out, it's 3 days from now. We don't know what, 2 days from now. Yeah, 2 days from now. We don't know what's in store, but I'm willing to bet something with Kotlin is going to be talked about even at this Google I/O, because Android has officially gone Kotlin first. And as of now, here we are. This slide might look different tomorrow, day after, depending on what gets announced at Google I/O. But why Kotlin? It's expressive. It is less boilerplate. As we said, Java is verbose, so Kotlin is less boilerplate. It has a very strong type system, so it provides you safety, nullability at the language level. It is interoperable. Now, this is one of the best parts about Kotlin. If you're using, it can work together with Java. So in the same code base, you can have 30% of your files in Kotlin, 70% in Java, or you could flip it. You could have 70% in Kotlin or 30% in Java. So that's great. It allows you to slowly add Kotlin to your code base while continuing to have Java. It allows you to write most of your code in Kotlin, but if there's some kind of functionality, legacy code, or some open source library that you're using that's in Java written and not in Kotlin, your project can safely compile without any issues. And it has structured concurrency. Pretty vast and deep topic. We'll not get into it, but I just wanted to put here for completeness sake. Let's quickly go through it. I know this was covered previously. Some of the key highlights, as I said, Kotlin, nullability in the type system. As you can see, the question mark is telling us that this function is nullable. So this parameter is nullable. This is great. It allows you to catch errors at build time rather than runtime. So you're upfront knowing that you should handle a nullable type rather than, when your user's using your app and there's a null coming in and you didn't handle it and the app crashes. Kotlin in this case wouldn't even let your app compile, so you would be forced to handle it. Another great thing, lambdas. I would highly recommend people read about lambdas if you're not familiar. It's a great programming toolkit to have up your repertoire. Then extension functions. It allows you to fix API problems in a very compatible and release agnostic way. It has template expressions, which means within a string, you can use a variable directly. Pretty powerful as compared to formatting strings in Java. And lastly, property access syntax for getters and setters, which means you don't need to worry about, hey, is my field, should I have a private setter or a private getter? Like all these kind of boilerplate code get abstracted away for you in Kotlin. Again, why would you want to use Kotlin? Number one, speed. Number two, speed. The speed of development in Kotlin is really, really fast. Again, as I say speed here, people's thought might go that if you're writing Android code in Kotlin, the app might compile faster or run faster. No, that's not what we are talking about here. It's just the speed of how you will be able to write your code, because you need to write less code. And also with the speed of Kotlin's language evolution, because it's a new language, it's constantly evolving, new features are being added. You'll get a lot more productivity boost by using Kotlin in your day-to-day Android programming. Some quick facts to sell you further about Kotlin. 60% of pro Android developers are already using Kotlin. 70% of the top 1,000 apps contain Kotlin code. And Google has been doing a lot of initiatives to adopt Kotlin, such as new tooling, lint checks, dedicated team, further optimizations that are happening. platform APIs are being annotated. So these kind of small little things actually make sure that your code is more correct. And here, I mean, the system will help you make sure that the code that you're writing is actually covering most of the scenarios, such as taking care of, is my parameter null? Should it not be null? Yeah, these are the two most important ones. And KTX are Kotlin extension libraries. So the idea here is, as I said earlier, the APIs were platform APIs, right? And if some improvement were to be made, you would have to wait for the new platform release to come out. But by using KTX libraries, what you could do is you could improve platform APIs, but outside platform releases. A quick example here would be, so this is a API inside Android SDK, create bitmap. This allows you to create a bitmap, which is an image you would want to show on the screen. And then you create a bitmap, you draw it on the screen, right? So this is like your old app code, like, 5 lines here, right? That's how you would write a code in Java, or not just Java, this is Kotlin, but how you would write a code using platform APIs. But with KTX, it can offer you an extension function, as we talked about, which is 2 bitmap. And then voila, your line of codes is just 1. So you can see how Kotlin makes your code so adds expressiveness to your code, makes it succinct and easy for you to program, and offload a lot of these boilerplate code to these KTX libraries, which are offered by the Android ecosystem as well as a part of the modern Android development initiative. So a lot of new libraries are out there which are Kotlin specific. You will run into these libraries as you're learning and building Android apps, and these are libraries and frameworks which are offered by Google now as a part of the modern Android. I'll just call it MAD to keep it short, as a part of the MAD initiative. So there's Room, Work Manager, Paging 3, and Jetpack Compose now, right? And there's a lot of docs training and samples that are available, code labs as well. Hassan has already linked them in the previous talk. Do have a look. There's lots and lots and lots of information available. So moving on, the next pillar, tools, Android Studio. Android Studio is your go-to IDE for doing Android programming. No longer Eclipse ADT is a thing of the past. We use Android Studio, announced in 2013, 2.2, which was one of the big releases. Constraint layout came in. Definitely recommend to check out. Constraint layout will help you put really nice layouts in Android. 3.0 with Kotlin support, 3.1 with more optimizations, a navigation editor for you to see how you're moving from one screen to the other inside your Android app, and you're building view binding, and motion editor. Motion editor is great. Like if you're looking to build Android, if you're looking to build animations for your Android app, I would highly recommend you check out Android Studio 4.0 and onwards, which has this motion editor, and it allows you to build really powerful UI animations right from your IDE just by using drag and drop. It's something spectacular and excellent and worth checking out. So a lot of other features that have been added because these tools are modern and now owned by Google. It has brought them the capability to actively develop it in the open and build new plugins and features which can be plugged in by Google inside the JetBrains IDE, which then becomes Android Studio. And because it's being built by Google and JetBrains together, it has a tight integration with Kotlin, the Gradle build system, lint checks, quick fixes, and integration with new APIs such as layouts, data binding, Room. So, this makes it better than Eclipse because Eclipse was not being actively developed and Google only had to build plugins to work with it. But Android Studio is an entire IDE that they can own end to end and build features on top. So it allows them to build a lot more powerful tools and features which really accelerate your development process as an Android engineer. All right, next up, Android Jetpack. So modern APIs in a model. So just like a little caveat here, by modern APIs, we would try to say, look, in an idle world, all APIs could be unbundled, right? It could be used all across the releases, but that's absolutely not possible. Like there's some APIs which are still a part of the platform releases as I talk about, that which happen annually, right? But a lot of APIs can now be unbundled and they become a part of the Android Jetpack. So we'll talk about some of them, not all of them. And I won't go into details of any of them. Like I just want to give an overview so that when you're looking for resources, when you're building an Android app, you know what kind of libraries and frameworks to use now. So constraint layout came out in 2017, excellent for building layouts for your app. Android architecture components, life cycles, view model group, great for building the architecture of your app or querying information from the database. Then you have paging in case you want to show infinite data or you want to load a new page. Like if you use Twitter or Instagram, they show you like 20 items in one go, and when you scroll further, they load the next set of 20. So that's paging. Navigation, how do you move from one screen to the other. Work manager in case you need to do some background work, right? Then you have the material design components, which is like how would you design your app, some type of scaffolding which is present and automatically available for you to build your app quickly upfront. Camera X in case you're looking to build camera related apps, so you don't need to really worry about diving deep into the camera itself. You can just use the Camera X extensions and build these quickly, get yourself up and running. And as I earlier talked about, motion layout and motion editor. So these are the kind of APIs that would be really, really helpful, like the kind of the libraries that you should look out for, which are no longer a part of the Android platform. They are unbundled. They are available as standalone libraries. They get updated every fortnight, if I recall correctly, with new features coming out. And because these are unbundled, you can use them like a standard third-party library, bundle them inside your app, and then ship it to the customer. And irrespective of the API version that the customer is running on, he or she will get all of the features that are available inside the new releases without having to wait for being backported to these previous app versions, right? So that's one of the great benefits that we have. Next up, we have, so another example that we can quickly talk about, or we can not, wait, I think my screen sharing just stopped. Is that true?
Yeah, I think you stopped sharing your screen.
I actually did not stop, but I just got an alert on Zoom. Just wait, why did it stop? Where did it go? Can you see it?
Yep.
Yeah, so where was I? That's funny. Yeah, so modern APIs, as I said, new releases happen frequently. New APIs are always consistently in development, and as they're available, they will be available to you every fortnightly, as you can track the release happening on the Android developer documentation website. More new libraries or APIs that are being released unbundled from the platform are like Jetpack Compose, Hill, Paging 3, everything is being built in the open. You could have a look and not worry about, hey, these are, when will they get to my customer? They will get to your customer as soon as you adopt them and as soon as you release an update to your app without having to wait for, oh, I need to wait for this Android update to actually reach my audience. And the Android team is focused on making that less and less, unless those are UI centric features, but your app centric features, the aim is to make sure that using the new modern Android development or the MAD APIs could accelerate your Android development and make sure the new features that you're trying to build are reaching your customers faster. Lastly, let's look at the distribution pillar. So we've covered languages, tools, apps. Now let's look at distribution. In terms of distribution, earlier we say the way your app is distributed to your customer is using APKs, but the new way to distribute your app is Android App Bundle. The Android App Bundle was announced in 2018. 2018 Google I/O, right? So what's the idea behind Android App Bundle? So let's look at it like this. So 3 out of 10 phones, like as per Google's internal data, shows that 3 out of 10 phones have less than 1 GB of internal memory space, right? And as users' memory space gets full up, they are more and more likely to uninstall some apps or unlikely to install a new app because they have no free storage available. And the idea with app bundle is that they actually, instead of serving the entire APK, they would only serve a smaller component of the application which is necessary for this user's device. So let's take a step back and understand what APK was. So let's say you're building an app for phone, right? Now there are billions of phones out there, right? There's a large screen device, there's a small screen device, there's a device with a very high screen resolution, like Apple talks about Retina display, Samsung Tech talks about their polished, I know what they call it, but there's super big, like there's great display devices, and they have a different mid-range of devices which have okay display or a substandard display. So, and what happens is if you have a substandard display, your images might not be that crisp, but on a super retina display, you might have really crisp images. So as you're trying to build your app, you would want to cover all the spectrum of devices out there. But as an end user, I don't care about the images or the quality of graphics for a higher end device, because on my device that's not going to be supported and I will not see it. Another example is, let's say, I'm using my phone in English, right? And your app supports 40 different languages. I don't need you to serve me like also download with your APK a Hindi language copy of your app, or a traditional Chinese or a simplified Chinese or any other language type of support for my app, because I'm only going to use it in English. So app bundles is that concept where it takes your APK and slims it down in such a way that the users only get what they need. And as you see, like here, the graph is showing you that as your size of the app increases, users are unlikely to download them. But as the app is smaller, users are likely to download them. So that's the great part about then having app bundles. Like if I can only serve a smaller component, as you can see in this graphic, I'm only serving a very tiny component to the user, which is like specific to their device, their density, and their language. That's it. I'm not sending them the other stuff. It's a smaller APK and users are very more likely to download that, right? So the good part about that is that you don't need to worry. The Android Studio has a very nice integration with app bundles, and they will take care of it automatically for you. So when you're building an app, they will ask you, hey, do you want to build an APK or do you want to build an app bundle? And you just need to select the correct option. If you're following the MAD practices, select app bundle, and Android Studio will completely take care of it for you without you having to worry about any of the setup issues with regards to this. But again, it's good to know that if you're distributing an app in these times, always choose app bundles. It's seamless, it's better for your end customers, and your users will be grateful that you helped save some storage on their device. And app bundles have had great uptake from Android developers. As we can see, like nearly 500,000 apps in production are using them. Nearly 35% of all active installs are with app bundles, and nearly 50% of all top apps and games are using app bundles. And at least 20% size reduction is visible if you're using app bundles instead of APK. And that's it. Just like language tools, API distribution, the core foundation for modern Android development. At the end of the day, language is Kotlin, tools is Android Studio, APIs would be architecture components, constraint layout, motion layout, camera X, MD, material design components, Jetpack Compose, Hilt, as I said, anything that's unbundled, distribution, Android app bundles. In case you're interested in more resources, have a visit at d.android.com or developer.android.com/modern Android development. And yeah, thanks. That's it from my side. Yeah, I'm good. Over to you.
Thank you, Mr. Saurabh, for the truly riveting sharing on modern Android development. We're now in the Q&A section for the workshop today, and we encourage everyone to ask any questions that you have on the YouTube chat. Please ask any questions. Okay, so for new developers, what should the go-to language be when learning Android development for the first time? Because some companies still prefer Java.
I can take that up. I mean, my recommendation at this point would be, like, as we discussed in the talk, would be go with Kotlin. It is extremely highly adopted right now. Most companies, from what I know, have moved towards Kotlin or are slowly adopting Kotlin in their code base. I understand the caveat there that companies still prefer Java. I would actually phrase it a bit differently. It's not companies prefer Java. It's mostly like if they have an app right out there, which has been there in the market for 7 years, 10 years, right? And Kotlin, as we saw in the presentation, was officially adopted by Google as a language for Android in 2018. Google and Android became Kotlin first in 2020. So we're still new in terms of Kotlin adoption. So a lot of apps are still have a lot of Java in their code base. And that, as we said, Kotlin and Java interop pretty well. And that really means you could have Kotlin code live by Java code together on the side. So companies are writing new code in Kotlin. It's just that a lot of their old code, legacy code, is still in Java. So you would have to know how to work with Java a bit, but learning Kotlin will give you a great head start because the future definitely looks like it will be dominated by Kotlin moving forward. So if you're starting off, go Kotlin, but it never hurts to slowly eventually try to build some knowledge about Java as well, because that will help in your day-to-day base. But Kotlin first for sure.
Do you have any more questions? What are some important concepts that are used in practice in tech roles that are beneficial for aspiring Android app developers to know?
Can you repeat the question?
Yeah. What are some important concepts that are used in practice in tech roles that are beneficial for aspiring Android app developers to know?
I'm not sure what this person is trying to ask. I think maybe like asking about some like journal best practices or something. So generally, like I think in my slide, right, I was sharing very basic stuff, but Saurav's slides was like a bit more detailed one. So generally, I think you need to use the, let's say, I mean, general practice is to, always use the latest library, make sure that your app works well with the latest Android OS. You need to keep updating your legacy code so that there won't be a time that, that code or that library is not supported anymore, and then it causes some issues. So generally, it's good idea to update libraries per quarter or on a, like every 6 months. At the same time, change your target Android versions to the latest one so you can get benefit of the new APIs. And then other than that, I mean, earlier we discussed about Kotlin, right? So it's like also important to use Kotlin and also like start writing unit tests and UI testing, so that if your code has some major changes, or let's say your API changes, then your existing code should not break. So these are some of the guidelines I can think of, but I'm not sure exactly what was the question. But yeah, I mean, if the same person is listening, can let us know like what exactly you want to know.
I think it answers the question. So let's move on. The next question is, I recently started working on Jetpack Compose and see that there are still components like MP Android chart that aren't well integrated to Compose. Would it be easy to port external libraries into Compose?
So what was the question? I think this will be for Saurav, right? Can you repeat the question?
Yeah. I recently started working on Jetpack Compose and see that there are still components like MP Android chart that are not well integrated to Compose. Would it be easy to port external libraries into Compose?
Right. So Compose interops pretty well with the current Android view system, the XML view system that we have, the legacy one. So in that case, MP Android chart or any other XML based library should work directly in Compose. Compose has a framework, a Compose view called Android view. And inside Android view, you could integrate anything that is XML based. So if you set up your core composable as an Android view, and within that you use any XML based view such as MP Android chart, it should work directly out of the box without any configurations or customizations needed for you. So Compose already has the infrastructure ready to support all these third-party libraries that are available out there. Having said that, another example I would like to add here is have a look at Jetpack Compose Cookbook. So that's Cookbook, COOKBOOK. That's a pretty nice open source library, which is showing you how can you build a lot of customized widgets and components inside Jetpack Compose. I highlighted that because I know it has an example for charting as well. So that Compose Cookbook shows you how you could build charts in Jetpack Compose natively. Like if you don't want to use MP Android chart and you want to use composables only to do it, Cookbook has an example and that should help you out in your specific scenario here. But if you run into some other third-party library, then I would recommend using Android View as your root composable and then using any other third-party library inside it. It should work.
Thank you for that answer. I think that was very helpful. So next question is, what is the best approach to building nearly complete or functional Android apps for a hackathon setting or a shorter time period?
I mean, if you're building functional apps, like it's not something which can be built in, let's say, 1 week, 24 hours, 48 hours. Like when we build functional, proper, complete Android app, there's a lot more that goes into it. There are like a lot of good programming practices such as solid design principles, dependency injection, these kind unit testing, integration testing. There are a lot of fundamental concepts that go into building an app, and a lot of stuff like these are overlooked, or not. I wouldn't use overlooked. They're skipped in terms of hackathon development because these are practices and patterns that you should follow because you're building a app which should be maintained over years or decades. But for a hackathon, it's about, figuring out what you really need to do versus what is boilerplate and is only needed because I would be working with a big team and it's maintenance plumbing. So for hackathon, I would say skip over the maintenance plumbing, just get the work done. Like have something which shows what you're trying to do. Don't worry about using best practices, great libraries or perfect integration. Like, but if you're building a proper real app, those things become really paramount. So it's important to draw that line between what's necessary and what's a good to have, and I can skip a good to have in terms of hackathon. Like I don't need them.
Yep. I think maybe consider Firebase databases, real-time database, because it's like the backend will be covered there, so you don't need to spend so much time on this. So that can even further simplify, because nobody's going to check your code. People will see your idea. So, and then is it working? There's an MVP product or something, right? So generally, you won't have time to write unit tests. You won't have time to try out new things like Jetpack Compose or something. But the idea is like to get your app up and running quickly.
Okay, yeah. So our next question is, suppose we were looking to make a prototype. Do you have any recommended tools we can use to make this prototype that complements those mentioned in the video?
Yeah, I think for more prototype is more like you are mentioning some UI storyboard or mentioning the app. So generally for the storyboards, I think there are some websites like Mockup, or there's another one, Prototype itself. I think the name is like that. They have a trial version. Can use this to build a storyboard or something. But other than that, I think you need to use the actual programming to build an app. There's no drag and drop kind of tool to build an actual app, but to showcase your idea, generally designers or product managers will use that. The product guys will use that to show their idea and also explain to developers. But generally for actual development, right, you need to download Android Studio, or you need to have all those tools to build an app.
Yeah, one extra tool I can call out would be InVision, that you can try if you're only prototyping.
Yes, okay. So our next question is that nowadays everyone is moving to Kotlin, as you had mentioned. Do you think it would totally take over conventional development like with Java and XML?
Not in the foreseeable future, as I highlighted earlier, like in the first, I think it was first or the second question, that a lot of apps are out there in the market which have been out there for decades. Like Facebook has been out there for, I don't know, probably more than a decade. Twitter has been there for 8-9 years. Instagram has been there for 8-9 years, right? Snapchat probably 6-7 years. It's tough for, code that was written 9 years ago, and it is battle tested. It works absolutely fine for us to say, hey, let's, rewrite that code in Kotlin. Like, that's not a good idea. Rewriting a code that really works, is tested, is validated by your users, that it has no issues. Just saying that I should rewrite it in Kotlin just because it's cool, it's hip, it's modern, everybody's talking about it. It's not really something which a proper engine, or not proper, like big engineering firms take up. Like, the time is well spent building new features for your users, right? So those kind of code will remain. They will remain for the foreseeable future. So I would say like Kotlin is looking like it is going down the path where it is the go-to choice for new features that we are building, and Jetpack Compose as the equivalent for XML. Like, it is the new way we are writing code. But to go on a whim and say, will that completely make Java and XML vanish. That's not going to happen. They will remain. I believe Kotlin and Jetpack Compose will become the preferred style, but that does not mean Java and XML will die. Like, they will continue to live on, at least for the foreseeable future. Maybe 10 years from now, the story is different, but at least for the next 3-4 years, I don't think that's going to happen. That's just my opinion. Like, I might be wrong, but yeah.
Why do app developers often neglect Android and write exclusively for iOS? Wouldn't it make more sense to release for both mobile operating systems?
Yeah, let me take this question. Generally, it's the other way around. So they write for Android, but often neglect iOS, because earlier, I think in my slides, I showed like almost 86% of the device worldwide by 2024 will be Android. So it makes more sense to target the majority, right? So, but generally, iOS and Android are two different platforms. Then I also showed like there are some hybrid platforms. You write one code base, but you target both iOS and Android. So generally, it depends on time to market as well. If you are short on staff and your app is pretty simple app, and then it has to go to market very fast, then you can have one developer who's building for both the platforms. But generally, this developer will be using a different kind of programming language, not necessarily Kotlin and Swift, but actually the functionality will be there. But if you want to extend this app and like build so many features, and then it becomes a unicorn company, right? Then it will be hard to maintain when new people come in. So that's why, I mean, it generally, like nowadays, people try to write both Android and iOS together, but generally Android is easy to release, easy to maintain, but at the same time they write iOS, but generally it's not the same developer who is doing, because those are two different platforms. Yeah, but you're right that it makes more sense to release both operating systems, right? Because in now there are all kind of users. Some prefer Android phones, some have iOS. Yeah, it's just based on the business decision, which market you are targeting, what kind of customers you have. So then after that, you can decide which platform to release first. You can release together, but you will need two developers if you are building natively. But if you're using a hybrid platform, then you can have one developer building for both. Yeah.
Okay, all right. Are there any tips to make Android Studio more memory efficient on less powerful day-to-day PCs? My laptop cannot run anything else when I use Android Studio.
I think Saurabh will be expert in Android Studio.
That's a tricky question. It's a great question. It's something which most people are like struggling with. One tip I can give you is, if you go to Android Studio, you go to preferences or just search for plugins. There's a plugin section. So it will tell you the list of plugins which are bundled with Android Studio and running. Go through the list of plugins and see what plugins you don't actually use ever, and just disable those plugins. So next to the plugins, there'll be a check mark, which the check mark indicates that these plugins are running. Remove the check mark or untick the ones that you don't use. Like some of the ones on the top of my head, which I feel like most people don't end up using, is like Mercurial integration, Subversions, GitHub, like in case you don't use a GitHub integration. There is Google sign-in integration. There is like Firebase integration. If you're not using these features of Android Studio, just disable them. And once you disable these features, you'll see small performance optimizations, like because these are less tools which are loading when you load Android Studio, they don't need to run. That should give you some improvements. How much will it improve? Your mileage may vary depending on the amount of plugins that you have enabled or disabled. But I think that's your best bet at the end of the day. Like, just to make Android Studio more performant. That's one. The other is there's an option in Android Studio, again, in preferences, like if you click on file, there'll be an option under preferences, and preferences you can search. There'll be an idea called heap size. So what you could do is you could try to increase the heap size. Now that is the amount of memory that is allocated to Android to run. You could try tweaking that. I don't know if it's 1 GB or 2 GB on your laptop. If you have a 16 GB laptop, maybe you can bump it to 4 GB, 5 GB. You'll have to play with that number to see. But apart from these two, I don't have any other advice. Like these two are your, try plugins first. Still doesn't work, try heap size then.
Yep. Also, I think you can like not run so many applications together. So I think you are already doing this. Generally, like your Chrome also takes a lot of memory, like so many tabs. And I think it depends on you're using Windows or Mac, right? There's some way to let you know the activity monitor. You can see which application is taking most of the time. Because generally when you are doing Android Studio development, right, then maybe it's better to like keep it more margin for this and don't run a lot of other applications as well. But if you're multitasking, right, then maybe you might consider using more powerful computer, because also, there is some kind of compromise we have to do as well. Yeah.
Okay. We have now come to the end of the Q&A session. Thank you so much, Mr. Hassan and Mr. Saurabh, for taking time from your busy schedules to share your valuable insights on Android technologies. I'm certain that our students here have learned a lot today. So this is a reminder for all participants to join the Discord channel if they haven't done so yet, and go through the starter kit for any other information pertaining to the event. For hackers, we hope you have started the ideation process for your hacks. The submission for the same is on May 16th, 3 p.m. Singapore time. With this, we have come to the end of our first workshop bootcamp. Do tune in on May 14th, 7:30 p.m. to 9 p.m. for another knowledge sharing session on Google Cloud Technologies. See you guys there. Thank you.
Thank you. Frank, have we stopped streaming? Or are we still streaming?